Thank you guys, and it's great to be back at CSS talking. I think it's actually 6 months to the day tomorrow, so it's really cool to be back. So as I was introduced, my name is Matt Fairbrass, and I work at a company called Lab 49, and we build web applications for investment banks, asset managers, and exchanges. And in my spare time, I like to game, mod, I'm a YouTuber, and my favorite frameworks at the moment are Angular and React. So today, I want to talk about scope, and specifically I want to talk about scope and how it relates to CSS. Now, what do I mean by scope? Well, put very loosely, I want to talk about scope in the context of isolating the parts of our program. And in terms of a very loose definition of a metaphor, think about scope as like a room in a house. If you want to go and have a private conversation in that room, you don't want that kind of conversation leaking out to the other parts of the house, especially if you live with the kind of housemates I live with. And we have this on the front end. So in JavaScript, they're called lexical scope or functional scoping, and it looks like this. And the code that sits within this inside the presentation function can access the code outside it, but the reverse is not true. So why is scope important? Well, for the first point is it restricts access to some of the components underlying implementation, and it allows us to define a very clear API and interface. Secondly, it facilitates the bundling of data with the methods, and I think the most applicable to CSS, it avoids namespace collisions or accidentally overriding other parts of the application with a later declaration. And so this is pretty awesome, but what about CSS? In CSS, everything exists in the global scope. And the problem is further compounded by specificity wars. So I'm sure many of you have run into this where you've got a more specific rule set declared, and no matter what you do, later rule sets won't override it, and then you have to use the dreaded important flag. So in this case, the background color will be red. And this kind of leaves CSS in kind of this kind of state where you really feel like you're fighting the language a lot of the time. So with all of that said, give me focus back. There we go. No. Tech fail. There we go. So with all of that said, how do we actually achieve local scope in CSS? Well, the old way of doing it used to be with language design methodologies such as BEM or Suit CSS. But this really isn't the right solution for the problem. You're just kind of hiding the problem. And the problems with language methodologies are that namespace collisions can still happen. And it's still a very manual process. In fact, it requires all of your front-end engineers to kind of maintain a mental model in their head of the entire code base. Now, for the kind of products we work on, we're talking thousands and thousands of different classes are used across a multitude of products. It's impossible to actually maintain that mental model, and you do get problems. Now, how many of you here, by a show of hands, went to web directions this year? How many of you saw Mark Dalglish's talk on CSS modules? Awesome. Right, so I'm going to touch a little bit on that because this, in my opinion, is the solution as it stands at the moment. So CSS Modules was written by Mark Dalglish along with the help of Glenn Madden, who wrote the ICSS spec. So what are CSS modules? Very simply put, a CSS module is a CSS file in which all class names are locally scoped by default. And they basically compile down into what's called an ICSS or the interoperable CSS format. But they look just like regular CSS files. And so the real benefits of using CSS modules is that you have no conflicts, your dependencies are explicit, and there is no global scope. So how does this all work? Well, when you're compiling down with CSS modules turned on, it will take your CSS code, which will look very similar to this, the source of the CSS, and it will transform it into something that's very unrecognizable. Or if you prefer, you can have a custom output style, so it's somewhat recognizable, but the most important thing is this hash at the end. And this allows us to guarantee that in the global scope, that the class names are going to be unique. So taking that mental model we had and the manual process we had before with things like BEM and Suit CSS, but actually automating the process. So how do you use this in your HTML templates then? Well, if you think about like the holy trinity of your web components, essentially, you've got your JavaScript, which is your behavior, you have your CSS, which is your presentation, and your HTML, which is your markup. And so there is an explicit dependency between these three things. And so in something like, you can use ES6 or you can use your common JS. In your JavaScript files, you would declare that, hey, I need this CSS file is a dependency, I need this thing. And so you would declare your CSS as a dependency, and then what CSS Modules is doing under the hood is basically creating a object mapping of those local class names to what it's going to generate in the global space. And then you use it as like an object string literal there and map it to your templates. And so what you get is this kind of compiled output, just like we see here. So what if you need some of your styles to actually be global? The common one being your body tag. You can actually explicitly declare that these styles need to be global, and it's very obvious what's going on in your code. This is going to be global. And I quite like this because there is an implicit kind of direction you're taking. And this is pretty sweet. So how do you go about using this? So what I'm going to try and do now is the dreaded demo. I'll tell you what, I'll go back to the slides. So I'll walk you through the steps on the slides, and then I'll show you the finished product, just because I'm trying to move things around between 5 or 6 monitors at the moment, and I'm getting very confused. So the first thing that we want to do is, and I will say this, so the demo I'm going to show you is using Webpack, but there are implementations for tools like Browserify. So the first thing we want to do is we're going to set up our project, and we do that by running npm init, which will just scaffold your project as an npm project. And then we want to install a bunch of dependencies, the most important one being Webpack and the Webpack dev server, along with the CSS loader, which is going to do all of the heavy lifting. The next thing that we do is we want to create a Webpack config. Now, this is a giant JavaScript file, but the most important line in this file is the loader line. Now, what Webpack does is it reads this line right to left, right? So we can see here the CSS loader is the loader that's responsible for transforming. And with the query parameter modules, I put it into what's called module mode, which is supporting CSS modules. And there with the identification name, I'm basically telling it how I want to transform my CSS. And the most important bit is the base64 hash at the end, which is that little kind of unique identifier. So the next thing as well, if you're using Webpack, you should probably be using the Webpack dev server. It's awesome. It gives you hot loading re-support. This is the Webpack server file. And then finally, the output that we get through running all of this is the CSS modules output. And I'm going to try and run that now. Okay, so here is a really, really terrible application, but I had 5 minutes to write this. So if we actually look at the source code for this, and we inspect it. This is so hard to do across two screens. Okay, let's make this bigger. Okay, cool. So we can see here that the CSS modules has generated these unique class names for me in the global space, and that's basically what I want to see. By the way, at the end of the presentation, there's a link to this project, and you can check out the steps to walk through how I add the different configuration parts. Hopefully, it's a little bit more explicit. But let's jump back to the slides now. Okay, and also in step 5 of the GitHub repo, I add preprocessor support as well. So if you're a big fan of things like SAS or less, you can still use those tools as much as you like. And then lastly, the last step, I show you how to break up the project into a more kind of build-orientated profile. So this is pretty awesome. So what are the limitations to using something like CSS modules? Well, the current limitations are it's very reliant on a JavaScript ecosystem. So if you're just wanting to do a really basic website where you're just doing some markup and some CSS, it's not really going to be a thing for you, because you still need to have a dependency on a piece of JavaScript that can require in the CSS for you. The styles are still technically global. It's being kind of obfuscated away from you. So namespace collisions, although would be extremely rare, they can still happen technically. And it does require a lot of build setup as well, which is a really daunting task for first-time users. The Webpack config, while the docs are good, it's super confusing at first. So there is a big learning curve. But I think it's a good start and a good step in the right direction. So what we're saying is we actually really need scope at a language level. And so what does the future of CSS scope look like? Well, there's been a couple of proposals, the first of which is the scope pseudoclass selector. And basically what this is an attribute you can put on a style tag, which you can host inline, where all child elements of the subtree will be styled accordingly to the scoping rules of that CSS. And it looks a little bit like this. Now, I don't know about you, but personally I hate seeing inline styles. I can't use my favorite preprocessors. It looks kind of ugly. But what they're basically saying here is anything under the section tag will be colored, any paragraph tags under the section tag will be colored red. Other paragraph tags on the page will be colored black. So moving away from that, then what was proposed was having this at scope at rule in the CSS. And what it effectively allows us to do is to define scoping for certain. And here we can see, even though the rule set that follows my scoping declaration is more specific, because this thing is scoped, the color of the paragraph will be red. However, browser support on this feature is really thin. And in fact, Chrome have dropped support for it. They supported it for a while under a experimental feature flag, but because of code complexity, they said, no, we're not going to support it. And they, in fact, are pushing and favoring the next thing, which is the Shadow DOM. And I'm pretty sure everyone here has probably heard of the Shadow DOM. But what it allows us to do is allows us to establish and maintain functional boundaries between DOM trees. It provides scope at a language level for HTML, JavaScript, and CSS. And it really does encourage component-driven development, so creating these kind of small, isolated components that are responsible for one thing and one thing only. And it's pretty cool. So for example, here we've got a little Shadow DOM example. It's on CodePen. So here, for example, I am setting this button with this text "Hello World," but you can see the output result is Lorem Ipsum, and it's because In my JavaScript, I'm creating a new shadow root context and basically not allowing outside things to modify that. So the TLDR, or the summary in this case, is that scope in CSS to date has been achieved through convention. Great things like BEM and Suit CSS that have kind of steered us in the right direction. And build tools like CSS Modules are helping us to automate these conventions, reducing the human error by creating a faux local scope. But ultimately, it's not solving the problem, and the future of CSS will be the likes of the Shadow DOM and these future specifications to achieve true encapsulation. Currently, the browser support is pretty light, but it's moving in the right direction. So thank you.